Hi, in this video we will onboard the fabric nodes to flatten an array to elements. The problem arises when nested normalized messages have to be transformed to lovely flat tables. For example, when it's needed to extract sold items from a check, decompose job positions from a resume, pull out names of artists from a movie, count aggregates, detect trends, or anomalies. Let's employ the fabric nodes. We'll run a project which produces a flow of messages having a timestamp and an array of elements. Subscribe to the flow of messages. Decompose elements from arrays. Produce a flow of the elements. Publish the flow of the elements to a cloud message queue. No code is needed. Open the Fabric Node Editor. Choose the Generate a Timestamp and an Array project. Open the project. Click the Emulate button to watch the messages the project produce. The project generates a flow of messages having a timestamp and an array of variable number of elements. Each element has a random key and a random value. Click the Download button to collect the sample messages. The project is ready to be deployed to produce messages continuously. Open the Amazon SQS control plane to watch the flow of messages generated by the project. The project produces and publishes one message every second. Return back to the project. Create a new project. Let's call it Flatten an Array to Elements. Open the project. You see a default Hello World project. Call a menu to add a new actor. Rename the actor to Array Subscribe. Link the actor with an output topic. Rename the topic to Arrays. Rename the Hello World actor to Array to Element. Rename the output topic to Elements. Call a menu to add a new actor. Rename the actor to Elements Publish. Link the Elements topic with the actor. Choose the Array Publish actor and call a menu to fall inside. Delete the JSON in node. Call a menu to add a new node. Choose the SQS read node. The node is used to subscribe to the Amazon SQS. Link the node with the JSON out node. The SQS read node requires additional configuration parameters. Get the name of the queue and the region in the Amazon SQS console. Use the Amazon IAM Identity Center to get the access key at an encrypted secret access key. The access keys are encrypted before stored. No one has access to your credentials. Repeat the steps for the element publish actor. The actor is used to publish the decomposed elements to the Amazon SQS queue. Choose the arrays topic. Upload the sample messages to the topic. We collected samples on the step before. The samples are used to test the actor and to generate output ports of the JSON in node. Choose the array to element actor and call a menu to fall inside. Click the JSON in node. Generate ports based on examples from the input topic. The JSON in node reads the samples, decomposes to elements, and automatically defines the output ports. The empty port is generated to transmit the entire message. Delete the empty port. We'll work with the elements of a message. Call the menu and choose the Array to Element node. The node gets an array to the input port, extracts element by element, and sends elements to the output port. Add a new port and rename to timestamp. We want to provide each element of an array with a timestamp. Reorder the output ports. Link the output ports of the JSON in node with the input ports of the Array to Element node. Change the type of data for the timestamp port. Call the menu and choose the Decompose node. The node is used to extract element from the nested objects. Link the output element port of the Array to Element node with the input port of the Decompose node. Add new ports to decompose a key and a value from the input elements. Click the JSON out node. Rename the default welcome port to timestamp port. Add new ports for a key and a value. Link the output ports of the decompose node with the input ports of the JSON out node. Link the output timestamp port of the array-to-element node with the input TS port of the JSON out node. The nodes are configured. Click the Emulate button and watch the results of the emulation. The JSON out node produces flat messages to the output. Return back to the project. Click the Emulate button to test the entire pipeline. The Elements topic got the flatten elements extracted from the arrays to publish to the Amazon SQS. The arrays topic consumed the messages having a timestamp and an array from the Amazon SQS. Open the Amazon SQS control plane. The Generate a Timestamp and an Array project produced 1,468 messages to the arrays queue. Return back to the project. It's ready to be deployed. Return to the control plane. Click the Reload button multiple times to see the amount of messages in the queues. The Generator project continuously produces messages to the array queue. The Flatten project continuously consumes messages, decomposes elements, and sends flatten elements to the elements queue. Both projects are deployed and continuously processing messages. What can you do next? Register in the Fabric node editor. Clone the project. Connect your own flow of events. Modify the processing logic. Connect the results to destinations. Share your project with your teammates. Make your project public. Welcome to Fabric.